Hi, my name is Nikola Markovic, and today I'll be showing you how to use the IoTConnect C SDK for AzureRTOS devices on a STM32L4 IoT Discovery Kit. The SDK is located at github.com at avnet-IoTConnect group. You will find the SDK in the pins section. Once you navigate to the SDK, make sure to read the readme.md instructions for the most up-to-date instructions in case they have been updated since the time of recording this video. Also note that we support two additional boards, which are the RT1060 from NXP and the SAM-E54 Xplaineed Pro board from Microchip. You want to get started by downloading the STM32Cube IDE. You can find it at sd.com website. Once you've downloaded and installed the IDE, you want to navigate to the releases page and download the IoTC-AzureRTOS STM32L4 zip, which is the source package. I've already downloaded the package and actually extracted it. So once you've extracted the package, you want to open the IDE. Now you'll be prompted to name your workspace. So select a name like STM32-demo and click the launch button. This will take a few moments. Navigate to the File menu, open Projects from File System. Navigate to the directory where you downloaded and expanded your source package. And drill into samples STM32L4. Click that directory and open. You want to unselect this root project and click Finish. Now this part will take some time, so we'll fast forward to the video to the point where this is done. At this point, we can close the Information Center tab. Make a note of the app config file, which is located at the sensors demo. Include. This is where we will enter our information about our device and our account. In order to set up a device in our account, what we first need to do is to set up a template. Once you're at the IoTConnect webpage, navigate to Devices, click the Device icon, and navigate to actually Templates on the left side and click the Create Template on the right side panel. For this demo, we will be using the symmetric key type authentication, but all these authentication types are supported in the SDK except for the TPM, which requires actual hardware to be present on the board. So I've already created a template for this demo, so I will show you the template. In my templates list, I have a template named STM32SYM. We can edit this template and I can show you the values that we need to have in there. Temperature being a number, humidity and pressure also being a number. And you need to declare a gyroscope value, which is object type, which will have X, Y, and Z as numbers inside the nested object. And similarly, you want to set up the magnetometer and accelerometer. The next thing we should do is to create an actual device that is based on this template. So let's call it STM32Demo. We'll pick the same name. Pick an entity that you belong to. And for the template, make sure that we select the template that we just created in this list. Click Save. Once that is done, ensure to click this Released button here, and that will activate and acquire your device. So now that we have created a device, we will need to get the information and enter it in the config file. So we want to copy the unique ID, which will be your IoTConnect DUID value. In our case, it'll be a custom device UID. Note that we can also have a prefix, and we automatically can generate the suffix based on your MAC address of your STM32 device. For this demo, we will not be using this feature, but we will just choose the STM32 demo as the name of our device. What we also want to be doing is in connection info, device connection, we want to copy the primary or secondary key, if you wish, and place it in IoTConnect symmetric key value. In addition to this information, we will need your IoTConnect CPID and environment name. These values you can find in the Key Vault section of your account. So in the settings Key Vault, you will find the CPID, which you can copy, paste into your CPID value, and copy the environment, which is QA. The Discovery Kit uses Wi-Fi to connect to the internet, so you will provide your Wi-Fi SSID and password in this section. I have already predefined those values in a header file, which I will be including here. And at this point, we are ready to debug the project. Make sure to connect your board to the USB cable to your PC, and at this point, we should be able to debug an STM32 Cortex-M C++ application. This process will take a while, so I will fast forward to the next section. Once the project is done building, you will be prompted with a dialog box where you edit your debug configuration. You can accept the defaults here and click OK. There will be one more build step, and at this point, we can choose to switch to the debug perspective. And we are ready to debug the board. We can just click resume. And if we open a terminal, on Windows I recommend TerraTerm, but I'm just using the GNOME terminal GTK term on Linux. And the board should take a few moments to connect and start sending data to IoTConnect. We should be able to verify this data at the device page. In the live data section. You can also check the latest value reported in this tab. For this demo, I prepared an IoTConnect dashboard where we can follow these values more closely and watch them live as they happen. So the temperature currently reported by the onboard sensor, which actually includes the board temperature heat, is 34.8 Celsius. The pressure in the room is 990 millibars. And here we can see the accelerometer values for X, Y, and Z direction as reported in thousands of 1G. Currently, the Z value is in thousands, so that means that the board is laying flat. If we put the board upright like this, the accelerometer X value should increase, and Z should go back to zero, near zero. And if we put the board in this direction, again, we should see the Y accelerometer value increase and the rest flattening out. That is all for this demo. Thank you for watching.